Okay, right. So in this video we are going to discuss about crystal field theory, right? So VB theory பார்த்தோம் இதுக்கு முன்னாடி, right? VB theory there are a lot of defects. What are the defects? So it is not able to explain the color and also the magnetic properties to a clear extent of the coordination compounds, right? Then what is the main defect? It is not able to explain properly whether the complex is a low spin complex or high spin complex. That is the magnetic behavior. So in order to overcome those difficulties, crystal field theory was proposed, right? This theory considers the bond between metal and ligand as a purely ionic bond. The bond is purely ionic. So in between ions, what is the force of attraction? It is nothing but the electrostatic force of attraction. It is electrostatic force of attraction, right? Also it considers the metal ions and the ligands as point charges, when the metal ion is positive and the ligand is negative. This is the metal and this is the ligand, okay, right. And also it considers as dipoles when the metal ion is neutral metal atom and the ligand is also a neutral ligand. So consider here, it considers the metal as well as the ligand as point charges in the case if they are charged. It considers them as dipoles when they do not have charge, that is a neutral metal atom may be present. And also in the case of ligands, neutral ligand, example ammonia is considered as dipole in the case of crystal field theory. So based on these assumptions, it proposes the bond formation, right, which it explains involving some hypothetical steps which we have to understand, right? See here. So actually the d orbitals are degenerate. Degenerate means all the d orbitals will have same energy. All the 5 d orbitals will have same energy. So let it be the energy level diagram. Here it is mentioned as energy, right? In presence of ligand, when the ligand approaches a metal, consider here it is the metal. When 6 ligand approaches, there will be a field created by the ligands. The ligands will definitely create a field. So ligands metal சுத்தி ஒரு field create பண்ணும் because all the ligands are electron rich and metal is electron deficient, right? So this field is called as octahedral field. Why? Because 6 ligands are approaching. Now what happens means the 5 degenerate d orbitals of the metal, because of the field created by the ligand, they will have an increased energy. The energy of them will be increased. Now also the 5 will have same energy. It is termed as barycenter. Before bond formation, the energy of the orbitals is increased by the field of the ligand, which is termed as barycenter, right? Now எப்படி அந்த ligands approach பண்ண, how the ligands are approaching, look here. So it is the x diagram, x axis. So it is the positive side, let it be the negative side. It is the y axis, it is the positive side and this is the negative side. And it is the z axis which is in front of the board and behind the board. It is the positive z axis and negative z axis, right? See here, let all the ligands are approaching the metal along the axis. All the ligands, ligand 1, 2nd, 3rd, 4th, 5th, 6th, all the ligands are approaching the metal along the axis, right? Among these 5 orbitals, we know dxy, dyz and dxz. Their lobes are along the axis. And their lobes are in between the axis. In between the axis. And dx square minus y square and dz square, these 2 orbitals have their lobes along the axis. Hence these 3 orbitals are termed as triply degenerate, T2G set. All the 3 orbitals are called T2G set and these 2 orbitals are called EG set, doubly degenerate. So what happens now? The ligands are approaching along the axis. So all the 6 ligands are coming along the axis. I will draw a diagram for you. So see here, for these three, any of these three, the lobes of d orbital will be present in between the axis. Whereas in this case, for dx square minus y square, the lobes are present along x-axis மேலேயே y-axis மேலேயே இருக்கும். Right? dz square எப்படி இருக்கும்? This is the z-axis, means it will be present as an electron cloud over the dumbbell shape. Right? Okay. So it is the T2G set where the lobes are present in between the axis, and EG set where the lobes are present along the axis. இப்போ நல்லா கவனி, ligandsலாம் along the axis வருது. ஏற்கனவே இவங்கலாம் axis மேலே இருக்காங்க. Ligandsம் along the axis. Ligands are also coming along the axis. So these two orbitals, that is EG set, will undergo severe repulsive force. Severe repulsive force. அதனால the energy of these two orbitals will increase because of the repulsion. Those repulsions are not felt by these three orbitals. So the energy of these three orbitals will decrease. Okay, what happens? See here. Right. So these 5 orbitals now will be splitted into 2 sets. See here like this. Why it is splitting? Sir, along the axis, these two will undergo maximum repulsion, higher energy. These three will exhibit lower energy because they do not have repulsion, because their lobes are in between the axis. Clear? Right. Now let me rub this. Right. See here, the total energy difference between these two is termed as delta O. Delta is nothing but crisp octahedral field splitting energy. Octahedral field splitting. It splits the orbital, isn't it? Splitting energy. It splits the 5 degenerate orbitals. Right. So how much is the splitting? See here, it is the barycenter, as I mentioned. This is the energy of this corresponds to the energy of the barycenter. Right. So how much it decreases, it is equal to how much it increases. Right. So totally 5 orbitals are there. So these 3 orbitals decreases by a portion of 2/5 portion. So 2/5 of the energy decreases, and here 3/5 of the energy increases. Since the energy decreases, we are mentioning it as a minus symbol, and here the energy increases, so we are putting it plus of how much? The total delta 0 of total delta 0. Simply you add these two, you will get the value delta 0. Okay, right. So hence in octahedral field, the triply degenerate orbitals will have lower energy, and doubly degenerate orbitals will have higher energy. So this will be the splitting of orbitals in octahedral field. Are you able to understand clearly? Right. Shall we go for the tetrahedral field splitting? So see here, 6 ligands are approaching. The splitting of the orbitals will be like this. If 4 ligands are approaching, how will be the splitting of the orbitals? Now we are going to see how the splitting will be there in tetrahedral field. Here we are going to discuss about the tetrahedral field splitting. How the field splitting occurs in the case of tetrahedral geometry, in the case of 4 ligands. See here. So these are the axes. This is the x-axis, and this is the y-axis, and this is the z-axis. Right? Okay. Here the 4 ligands are approaching. How the 4 ligands are approaching? See here. This is the ligand 1. This is ligand 2, ligand 3, ligand 4. The angle between them is how much? 109 degree. So considering the angle and the strain with which the ligands are approaching, we can clearly understand. In case of octahedral, the ligands 6 ligands approaches along the axis, whereas in the case of tetrahedral, the 4 ligands they do not approach along the axis, they approach in between the axis. So among the T2G set and EG set, T2G orbitals are the ones which are present in between, right, as I mentioned earlier. So these will undergo maximum repulsion, and their energy will be a maximum one. So in the case of tetrahedral field splitting, the energy difference is called tetrahedral field splitting energy. See here how the splitting will be. Here the 2 energy orbitals, the EG set, the EG set will have lower energy, and the 3 orbitals, that is the T2G, will have higher energy. Just inverse of that of the octahedral field splitting. Okay, right. So the difference in energy is called as delta T. So delta T is nothing but crystal field splitting energy in case of tetrahedral field. Okay. How much the decrease in energy will be? It will be equal to the increase in energy. How much the decrease will be? See here, the 3 orbitals, the energy increased by those 3 orbitals will be decreased by these 2 orbitals. So the decrease in energy will be minus of, see here, minus of 3 by 5 times of delta T. How much will be the increase here? The energy decreased by these 2 orbitals will be increased. So 2 by 5 of delta T, this will be a positive one. Since the energy is increased, it is positive. Are you able to understand clearly? So what is the main thing is that in the case of octahedral field, 3 orbitals will be here and 2 orbitals will be here because of the repulsion forces. In the case of tetrahedral field, the same thing is reversed, that's all. 2 orbitals will be having lower energy and 3 orbitals will be having higher energy. So that's all about the splitting in case of octahedral and tetrahedral field. Okay, if you are able to understand this clearly, it is not at all a task to clear the next concepts of this crystal field theory.